Okay, so today, what is it, the 7th? Yeah. 1/7/19. Okay, on Friday we talked about the tangent. All right, what I like about this book, it's the only book that ever does this, is it does this in 2 days, which makes it easier for you. Instead of doing the whole thing in 1 day, we do it in 2 days. Meaning that we did tangent on Friday, and today we're just going to do sine and cosine, okay? So, if I want to find the length of AC, let me just call that x, all right? Again, always start with your angle. In fact, let's write that down. Always start at the angle, okay? Always start at the angle, okay? So you go to the angle, and then the names come from the angle, okay? So if I'm at the 34-degree angles, then the 6 is my opposite. What I want to find is my hypotenuse. Okay? I don't care about the adjacent this time, but what I want to know is the hypotenuse, all right? So opposite hypotenuse, I've got all 3 trig ratios up there, and opposite hypotenuse has to be the sine, right? So if I write it as the sine of theta equals the opposite over the hypotenuse, I don't really want the words, I want the numbers. Okay? But I picked the correct one because I want the opposite and the hypotenuse are the 2 I'm using. So instead of this little symbol, theta, it means angle. So I'm going to put 34 degrees because this means angle. So I'm going to go sine of 34 degrees equals the opposite, which is 6, over the hypotenuse, which is x. Okay? Now, if x is on the bottom, we will divide. And I'll show you. The first thing I'm going to do is try and solve. So I'm going to cross multiply. I'll bring up the x.
What if there's 2 angles? How do we find out which one is the theta?
Great question. You can choose either one. If you do both angles, it's your choice. Good question. You just whichever one you want to choose. Okay? And if we chose the other angle, Lana, we'd be using cosine. But it would still work. Okay? And we can find the other angle. In fact, when I flip the page, we're going to do that, okay? So I bring up the x, and it's going to be x times the sine of 34 equals 6. Again, this is a number in my calculator. So I'm going to divide by sine of 34, divide by sine of 34. And so I'm just going to use my calculator. I'm just going to go, okay, what is 6 divided by my sine of 34, and I get an answer of about 10.7. X equals 10.7. Now, again, always ask yourself this easy question when you're done. Does your answer make sense? Could this side be 10.7? Sure, if that's 6, right? That's 6. That could be correct, and it is correct, all right? So the sine ratio. Sine of any angle is always equal to the opposite side over the hypotenuse, right? Let me answer Landon's question. Landon, this angle here, angle A, would have to be, let's see, what's 90 minus 34, would be 56 degrees. I could have done it this way. It doesn't matter. I could have picked this other angle, and I would have used cosine. You say, why I would have used cosine? And I'd get the exact same answer. From this angle, that's my adjacent over my hypotenuse, and I'd get the exact same answer. Okay, and we're going to do that. Okay, let's keep moving on. Okay, next example: given triangle PIG, find the length of IG. So let's call IG x. Okay, we will eventually call it little p. That's how we label these. Okay, so IG is x. Always start with the angle. So here's my angle, right? And then label the names by the angle. I don't need the opposite, but I want to find the adjacent, and I have my hypotenuse, okay? So to set this up, I'm going to use the adjacent on the hypotenuse, and I'll look up there, okay, which one is it? It's got to be the cosine. So I'll go, okay, cosine of theta is equal to the adjacent over the hypotenuse. That's what my ratio says on the board. Instead of theta, I really want to put the numbers in because these are just the words. So let's use this formula and put the numbers in. So instead of theta, I'll put 40. So I'll go cosine of 40 is equal to the adjacent, which is x, over the hypotenuse, which is 12, okay? And then if I want to solve for x, I'm just going to multiply up to 12. So if I multiply up to 12, I'll have 12 times the cosine of 40 equals x. Now x is already solved for. I don't need to divide or anything. X is already by itself. So in this case, I'll just multiply it. I'll take my calculator and I'll go 12 times the cosine of 40. And again, it's about 9.2. I'll round that up to 9.2. Okay. All right, so the cosine ratio. Sure. Cosine of theta is equal to the adjacent over the hypotenuse. Okay? Not too bad. So now we know all three. We know the sine, the cosine, and we know the tangent. And we should be able to solve any right triangle using any of these three. So let's turn the page. Okay? Let's turn the page. Let's see what we got. All right? So, example 1. Solve triangle ABC. Okay, now, there's a lot we're going to have to find angle B. We're going to have to find little a. Now, we call it little a because if this is angle A, then the side opposite we label as the same angle, okay? Angle A, little a. Angle B, this would be little b. Angle C, this would be little c, okay?
But little c's already fine.
Yep, so we already know it. Exactly, so we don't need to label it all. Now, if I want to solve this, then I've got to do a couple of things. I need to find angle B, and that's actually pretty easy. You don't need trigonometry to find angle B. We're going to find little a or little b, okay? So let's do this. So first of all, the easiest thing to find first is angle B, okay? You guys agree? Angle B.
90 plus 38.
Yeah, so I know that these two angles have to add up to 90. They have to add up to 90 because out of 180 degrees, 90 is already used, right? So to find angle B, I'm just going to go angle B is equal to 90 minus 38. That's it. Those two angles have to add up to 90 because the other 90 has already been used. So 90 minus 38, and I get an answer of 52. So angle B is 52 degrees. Okay, now we need to find either little a or little b. Everything starts from the angle. Now Landon said something about can you use the other angle? Sure. You have two angles. Don't use the 90, okay? Never use the 90. Use the, so it doesn't matter. I could either use angle A or angle B. So, I don't know, Annika, what's your favorite? Do you want to use B or A? It does not matter. So we're going to use angle A, okay? And let's see. Who do I want to pick on? Hannah. Doesn't matter. Hannah, we could either find little a or little b. Which one do you want to find?
Little a.
Little a it is. And so it does not matter. We're going to find both anyway, so it's just a matter of whichever one you want to choose. Now, Hannah has, though, forced us to use sine. If she'd picked little b, she would have forced us to use cosine, but you forced us to use sine. Now, why do I say that? Why do we have to use sine?
Because it's the opposite angle in the hypotenuse.
Opposite and hypotenuse. Right. Okay, so we're going to use sine. Everybody agree? From the angle, we want to find the opposite. We know the hypotenuse, so we're going to set up sine of theta equals the opposite over the hypotenuse, right? My opposite is A. My theta is 38 because Annika picked the 38, right? So sine of 38 degrees equals A over 15. How am I doing? It's really, yeah. So it's really not that bad, is it? Right triangle trig, it sounds terrible, but it's actually a lot easier than some of the other stuff we've done, right? Okay, let's solve. So I'm going to multiply up by 15. Bring the 15 right there. And I'll have a 15 times the sine of 38 degrees. Okay? So then, just use your calculator because that's going to be little a. I already have a by itself. I don't need to divide. I'm just going to go 15 times the sine of 38. You can see it in my calculator. I get an answer of about 9.23 or 9.2. 9.2 equals little a. Okay, 9.2. Okay, now, if I have to solve this triangle, I've got to find everything. So what I've found so far is I've got angle A, I've got angle B, and I've got little a, but I don't know little b. Okay? So I've got two choices. Pythagoras theorem will work. Or cosine. It doesn't matter. Well, adjacent over hypotenuse. If I want to find little b, I could use cosine because from the angle, that's my adjacent side over my hypotenuse.
Wait, but you can also use sine.
I could also use sine if I use 15
Wait.
degrees. Yes, let's not confuse it. It's totally correct, yes.
Yeah, that's what I'm saying. So wait, why can't we do, is it sine supposed to be angle 52? So
Wait, back up.
angle A adjacent.
Okay, hold on.
I mean.
Let's go back. So you want to go back to this one?
Well, because, well, A is adjacent to angle 52, right? And you're doing the sine.
Okay, okay, hold on. If we pick 38, opposite, you agree opposite hypotenuse.
Okay.
And so I solved and I got little a, right? Okay, you okay with that?
Yes, but what I'm saying is why can't we use the sine or whatever for B angle?
Nice job. Yes, and that's what Caleb said. And I said, let's not confuse them, but you're totally right. So, Zoe, you can pick either angle. So if you pick the 52, we'll use the sine, won't we?
Yeah.
If you pick the 38, we'll use cosine. It doesn't matter. Either way. So, or, you ready for this? Or we could even use Pythagoras theorem, right? We've got b squared plus 9.2 squared equals 15 squared. So you got 3 ways to do it. Does not matter to me. Okay? So which way? Quinn, what do you want to do?
Yeah,
Do you want to do cosine, sine, or Pythagoras theorem?
Pythagoras theorem.
There you go. So let's go b squared plus 9.2 squared equals 15 squared, right? Yeah, or Zoe, why don't you do the same thing but do sine of 52, okay? Caleb, why don't you do cosine of 38? We should all get the same answer, right?
Yep.
So I should have a b squared plus, I don't know, it's 9.2 squared. And there's about a 84.64 equals 225. However, the other way, using cosine is going to be more accurate because you should get the same answer. I've rounded a little bit, minus 84.64. Okay, 225 minus 84.64. I get b squared equals 140.36 square root, right? And I can answer about 11.8.
Yeah.
Now, anybody do it a different way?
I'm doing.
Did you use cosine?
I use both.
You used both and you got the same answer, didn't you?
Wait, so we're looking for small b now?
Yeah, small b.
Okay.
And I got 11.8, okay? Now, real quick, here's the deal. All you got to do is choose which one you want to do. So if you choose an angle and choose a side, it's going to determine which one of those you use, right? But you start with the angle, okay? Now, last but not least, number 2, find the area of this isosceles triangle. Now, we know the area of a triangle is equal to 1/2 base times height. I don't know either one. I don't know my base, and I don't know my height. But what I will do is draw it straight down the middle and make a right triangle out of it, okay? So I'm going to go straight down the middle, and I'm going to make a right triangle out of it. Now I want to find the height, so let me first of all superimpose this triangle over here, okay? So I'm going to superimpose it, draw it over again. Here's what I have. This is 18, and this is 22 degrees, okay? I need the base and the height. So let's find the height first. Call it h, okay? Let's find the height first. Let's call it h. And from my angle, or even this angle,
Let's do the 22.
let's do the 22, okay? It's going to be adjacent and hypotenuse, right? Everybody agree with that?
Yes.
Okay, so if it's adjacent hypotenuse, it's going to be cosine. So we'll set up cosine of 22 is equal to my adjacent over my hypotenuse, right? So I'm going to get the height of the triangle because I'm going to multiply up the 18. So let's multiply up the 18, bring it up there. Let's go 18 times the cosine of 22 equals h. Okay, 18 cosine of 22. And I get an answer of about 16.7, okay?
We only skip a couple of things.
So I know the height. So let me go back to this triangle, and I've got it to be about 16.7. All right, again, to find the area of this triangle, I need the height and the base. I need to know the base. I do not know the base.
So Pythagoras.
So I could use Pythagoras Theorem, sure. Why not? Call this x, okay? And I go 16.7 squared plus x squared equals 18 squared, right? Or I'm going to skip a step, but I think you'll be okay with that. 18 squared minus 16.7 squared. You okay with that? I'm just going to let my calculator do that. You okay with that? I know Mr. Bard showed that to you when you guys were in 8th grade. Okay, I just brought the 16.7 squared over. So 18 squared minus 16.7 squared. Okay, and then I got a 45.1 square root of that answer. And I get about 6.7. Okay, now.
Wait, but that's a negative square root.
No, that's Nico sign. Good question. Thank you, Zoe. Yeah, that won't work. Okay, so this is 6.7. Now, what's the base of the triangle? It's not 6.7, but all the way across, right? Yeah, it should be times 2. 6.7 times 2 is 13. So the whole base of the triangle is going to be a 13.4. So we can do this now. Here's my base. Here's my height, right? We can do this. This problem's going to be, all right, area is equal to 1/2 the height, which is 16.7, times the base. Whoops, I got these backwards. It won't matter, though. 13.4. So 0.5 times 16.7 times 13.4, and I get an answer of about 111.89. And that'd be in terms of centimeters squared because it's area. Okay? All right. That's all I have. I've got homework for you. Isabella.